Okay, in this example, we'll deal with a simply supported beam. So here, this simply supported beam consists of a section with I and E, where the loading shown here determine the beam deflection at point D. Okay, at point D here, this is our target. So after the loading, it will be deflected in this way. So we're determining delta D here. Okay, it has two loading. So simply we can just split them into two concentrated loads. Okay, this case, we're determining delta D. Y can be split into concentrated load PD by the delta D1 plus another case PB only. Right here you have delta D2. Okay, so we can simply split it into these two simple cases. In the first case, of course, we can simply consider that here is a A, here is a B. Right, then you can easily find the equation from our big table. Right, the case is right here. Right, so the equation we use will be this one. Right, the equation 6. But just keep in mind that equation 6 can only be applied to this range, x from 0 to a. Okay, let's write this equation first of all here. The equation will be delta x equals negative p b x over 6L EI by L square minus B square minus X square, where the X is from 0 to A. So you cannot use this equation to calculate deflection of a point between X equals A to X equals A plus B. Okay, keep this in mind. So then let's just look at the first case. Okay, in beam 1. Okay, in beam 1, we just need to determine what are the values of A and B and L and X, etc. This is what we need to calculate the delta from this equation. This is our equation 6. Right. So if you look at beam 1, the A equals, if you consider only here, this is our beam 1. Okay, if I only consider the PD, then the A will be AD. Right, this AD equals AB plus BD, and you can find the numbers here. AB is 1 meter, BD is 3 meter. So here's 1 plus 3. You got a 4 meter or 4,000 millimeter. And the B, as shown here, the B is just DE. Right? B equals DE. So that is 2 meter or 2,000 millimeter. And the L, just add the 3 sections together. 1 plus 3 plus 2, you got a 6 meter or 6,000 millimeter. So at point D, this is our target point. I just said the X equals what? As shown here, when your X start from A, towards E, so the x value at point D should equal A, right? It equals A. That is 4,000 millimeter. Now we can calculate the first components of this deflection. Delta D1 equals, just use that equation, right? It's a negative P, that P is 20 PD, that is 20 kilonewton, or 20 by 1000, by B, the B here is 2000, by L, by X, and X here is 4,000 over 6 times L, that is 6,000, times E, E here is 200 gigapascal, that is 2 by 10 to the 5th MPa. Then by 274 million. Then by here, this is L square, this is 6,000 square, minus B square, this is 2,000 square, minus X square, this is 4,000 square. Okay, the result of this equation will be negative 1.3 millimeter. Then we can calculate beam 2. Okay, beam 2 is here, and here's our beam 1, and your beam 2. As we mentioned, if you want to use this equation, you cannot directly use it, because in beam 2, if you do not change the x coordinate, the x starts from the left-hand side, right, the x, then your A is here, and then your B is here, and the target point D will be located between A and A plus B. You cannot use this equation since it's only applicable to x. X equals x is within 0 to A, right? So you cannot use this equation directly. So to use this equation, we need to change something. We need to change the direction of the x coordinate. Okay, so here the change we're making is that to set point E as the origin of x coordinates, we said that x starts at E pointing A. Okay, this is the opposite x direction as compared to beam 1. So in this way, when the PB is added, then the A will be here and the B will be here. Okay, so in this way, let me determine those parameters to fit this equation. So here the A will be BD plus DE. That is 5 meter or 5,000 mm. And the B will be just AB. That is 1 meter or 1,000 millimeter. And L is still 6,000 millimeter. So what is the x coordinates, x of point D? So at the target point D, x equals what? Point D is here. So obviously the x equals DE. That is 2 meter. Or 2,000.
Darren is at front door.
Or 2,000 millimeter. Then use the equation our delta D2 can be calculated by negative 45,000 by 1,000. This is the B value. By X value, X is 2,000 over 6 times L, this is 6,000. By E is 2 by 10 to the 5 by 274 million. Then here you will have L square, that is 6,000 square, minus B square, B is 1,000, minus X square, that's 2,000. Here you will have negative 1.41 millimeter. So finally, our deflection at point D will be calculated by just add these two values together. Right? It's, the first one, the second one. It's negative 1.3 minus 1.41. You get 2.71 millimeter. So that's it.